This is problem number 1 from section 5.1. In this problem, they want you to use finite approximation to estimate the area under the graph of f of x equals 4x squared and above the graph of f of x equals 0, and they want you to evaluate this from 0 to 6. So we have part A, part B, C, and D. The first two parts, they want you to do a lower sum. And if you remember with the lower sum, if you watch the videos that I had in my playlist, a lower sum means our rectangles want to be below the function. So they want to be below the 4x squared function. None of the rectangles parts should be above the function. On an upper sum, we're actually going to be above the function and below the function. So it's going to be, this is going to be an overestimation of the area, the upper sum will be, and the lower sum will be a lower estimation of the area. So this is kind of nice because this details what integration really is. So integration is obviously finding the area under a curve, and how we get to that is we essentially make rectangles, but we essentially use rectangles to find the area under the curve by increasing the number of rectangles under that curve. So 2 rectangles gives me an estimate, 4 rectangles gives me a better estimate, 8 rectangles gives me a better estimate, so on and so forth up to infinity, which gives me obviously the best estimate. So let's go ahead and start with part A, and let's draw the graph to begin. So for part A, our graph is going to be this 4x squared graph, and we're just going to look obviously in the upper right hand corner because it says 0 to 6. So x value of 0 here, x value of 6 here. Now the function f of x, well, first of all, f of x equals 0 is this line, which is the x-axis. Our other function is f of x equals 4x squared, which would look like this. If we plug in, well, let's go ahead and plug in f of 6 because that's our boundary point. F of 6 would be 6 squared, which 6 squared is 36, times 4. 36 times 4 is 144. So at this point here, the function is 144. So we have a parabola that looks like this. It's slowly going to increase up to that point there. So this is what our graph looks like, and we're going to draw this graph 4 times. And in those 4 times that we draw it, we're going to do a different set of rectangles for each to estimate the area. So for the first one, it says a lower sum with 2 rectangles of equal width. Well, if they're equal width and our distance in the x direction is from 0 to 6, that means that each one of these rectangles has to be 3 wide. So one's going to go from 3 to 6, one's going to go from 0 to 3. Now lower sum just means my rectangle needs to be below this function here, which is f of x equals 4x squared. Well, if it's going to be the width and I want to cover the most area, this spot can go all the way up to the function line and not go over it, which means I need to draw a straight line across to the 6, and there's my first rectangle. It's got a width of 3, it's got a height that we have to find still, but its width is 3. This other rectangle, its height, it has to be 0 because 0, 0 is the first spot in our f of x domain range. So this has got to have a height of 0. So this darker line right here just represents our rectangle that has 0 area, and this other rectangle is our second one with the same width, but it has a little bit of area. And you can see this is going to be actually a fairly bad estimate of the area under the curve, but this is how we come up with the area under the curve using rectangles. So here's what we'll do. We'll label this 1, label this 2. So rectangle 1 has a width of 3 and has a height of 0, so it has an area of 3 times 0, which is 0. Rectangle 2 has a width of 3 because they have to have the same width, but its height is, well, its height is going to be this function, 4x squared, right, with an input of 3. So that height value would be essentially f of 3. So we're going to say f of 3 equals, and I'm going to use the calculator to do this. So we're going to set 3 and we're going to store it as x. And then we're going to type in 4x squared, hit enter, that's 36. So my height is 36 there. So the area is 3 times 36, and 3 times 36 is 108. So the area under curve, and we should say area under curve, is 0 for the first rectangle plus 108, which equals 108. So our first estimate of the area between f of x equals 0 and f of x equals 4x squared is 108. And we know that's not even close, because look at the gap they got here and look at the gap that's here where they're not incorporating those areas. All right, so let's go ahead and do part B. So for part B, we're going to draw the same graph. So I'm just going to be quick with this. Same graph. 0, 0. This is 6. 144. Mark that point. Draw this up. Now the difference here is going to be, that instead of using 2 rectangles in the previous problem, right, we used 2 rectangles. Now we're going to use 4 rectangles. So we're going to split this width, which is from 0 to 6, and we're going to split it into 4 rectangles. Well, what's 6 divided by 4? That's real key. 6 divided by 4 is 1.5. So each rectangle has to have a width of 1.5. So I'm going to mark, this is 1.5. Here's 3, and here's 4.5. So that's 4 widths of 1.5, so I can have 4 rectangles. And I'm doing a lower sum, so I draw the first rectangle until it touches that line, right? I'm going to use the inside dimension, because if I use the outside dimension, I'll draw it up, and then I have to draw it over, and then I'll be above the line. So I use the inside dimension to draw my first rectangle. I use the inside dimension to draw my second rectangle, and then my third rectangle. And finally, my fourth rectangle has a height of 0. You can see between the 2 graphs, this is going to be a better estimate so far than that one was. So let's go ahead and label these. This is 1, this is 2, this is 3, and this is 4. So we're going to find rectangle 1 has a width of 1.5 and it has a height of 0, so its area is 1.5 times 0, which is 0. Easy. Rectangle 2 has a width 1.5. Its height is f of 1. Well, its height would be, rectangle 2 would be whatever 1.5 is, right? So this 1.5 is that spot, whatever that height is, whatever that y value is, that'll be the height of the rectangle. So f of 1.5 is what we want to find. So if we do f of 1.5, again, 1.5, store it as x, and go up and grab 4x squared. That's 9. So the height there is 9. So the area is 1.5 times 9, which is 13.5. Now we do rectangle 3. Again, the width, 1.5. The height is f of, for rectangle 3, it's f of 3 now. All right, 3, store it as x. Grab that function. That tells us it's 36. So then we'll take the area equal to 1.5 times 36, and 36 times 1.5, 54. So now we're going to do rectangle 4, and again the width is 1.5, the height is f of 4.5. If we take 4.5, store it as x, grab that function one more time, now we get 81. So we do 1.5 area equals 1.5 times 81. 1.5 times 81, 121.5. So we get 121.5. So the area under curve is 0 plus 13.5 plus 54 plus 121.5, which equals 189. Now notice for part B, our area increased because we're actually covering more area under the curve. So what happens if we increase the rectangles to 8? Well, you're going to get even more area under that curve. But instead of doing that, there's also a way to estimate using an upper sum. So we're going to do part C now. So we'll go ahead and switch this out. Okay. So part C it is. We're going to draw the same graph that we did before. Part C. Here's the graph. And actually, I'm just going to draw the graph for both of these at the same time. So 144 for part C. That's this point here. Now, if I draw an upper sum, now I want my triangles to be, or my rectangles to be larger. So this is 6. It says an upper sum with 2 rectangles of equal width. Well, equal width, again, we have to have 3 for a width for each. But this time, we're going to go with the larger rectangle. Instead of going underneath here, we're going to go with the outside or largest value and draw this over like so. So now we're going to have an estimation of the area, because now we go to the 3 instead of the 0, and we have our second rectangle right there. So this is going to be an overestimation. If I draw part D here at the same time, this time I'll have 4 rectangles, so my widths need to be 0 to 6. Mark this point. Now my widths need to be, if I take 6 divided by 1.5, just like we did earlier, or not 6 divided by 1.5, 6 divided by 4 rectangles, it gives you 1.5. So 1.5, 3, 4.5. Again, I'm doing an overestimation, so I'm using the outside dimensions. I get this rectangle. I get this rectangle. Notice that every time I'm touching where the function and 3 meet, or function and 1.5 meet. And now I have an overestimation, so I have some extra area that I'm including in there. So I'm actually going to be larger than the actual area under the curve. But we do this process the same way. So we're going to call this rectangle 1, rectangle 2. So for the 2 rectangles, rect 1 has a width of 3 and a height of, now we look at f of 3. So f of 3 means I'm going to take 3, store it as x, go up and grab that function, 36. So my area for this one is 3 times 36, which is 108. So my area for rectangle 1 is 108. Rectangle 2, my width is 3. The height is f of 6, right? F of 6 is the height. So I plug in 6 stored as x. Go grab that function again, 144. So the area is 3 times 144. So let's just take that times 3, 432. So now my area under curve is estimated at 108 plus 432, which is, if I do 108 and 432, that is 540. Now, if you compare the 540 with our previous estimates, and I'm going to kind of write those up here, we had 108 for this one, and I believe, if I look back, we had 108 and then 189. So 189 for this. So you can see 180, 108, 189. Now we have 540. All right, that's a big jump. So we're definitely overestimating there. This one will give us a better estimate, though. This 4 rectangles will give us a better estimate. So let's see. We're going to label this 1, 2, 3, and 4. So rect 1, it has a width of 1.5, and it has a, I'm going to slide over a little bit, has a height of, well, f of 1.5. So f of 1.5 we're going to take 1.5, store it as x, grab the function, that's 9. So the area is 1.5 times 9, which gives you 13.5. Rectangle 2, width 1.5. Height is f of, now we're doing f of 3. Well, we know f of 3 to be, if I just look over here, f of 3 was 36. So I'm going to write 36 there. So my area is 1.5 times 36, and that'll give me 54. Rectangle 3, width 1.5, height f of 4.5. So if I go 4.5, store it as x, grab that function, 81. So I have area equals 1.5 times 81. So 81 times 1.5, 121.5. And then finally I'm going to f of 6, right? So rectangle 4, width 1.5, height f of 6. So 6 stored as x, 144. So I end up with area equals 1.5 times 144. So the area is 144 times 1.5, 216. So the area under the curve, we'll slide up a little bit. Area under curve, it's estimated to be 13.5 plus 54 plus 121.5 plus 216, and that equals 13.5 plus 54 plus 121.5 plus 216, 405. And notice that that number is smaller than the 540, and we are getting closer and closer, right? The more rectangles you use, the closer and closer to the actual area. Now, we know then our area, because of our lower sum of 4 rectangles of 189, because of our lower sum of rectangles for 4 rectangles being 189 and our upper sum of 4 rectangles being 405, that the area, we could say the area is between 189 and 405. I hope that makes sense. I hope that makes the integration makes sense, the stuff that we've been working on.